Okay, so as I said in class, I wanted to do a few problems with some solid revolution topics. We started on Friday to talk about this one particular solid revolution where there's a hollow inside. So we were looking at the toilet paper. If you imagine this is a toilet paper roll right here, the width of the toilet paper, I'm just going to make up some numbers. Let's say it's 9.5. Let's say that the big radius from the middle to the outside, we'll say that that is equal to 5, and these are centimeters, by the way. Let's say that the little radius, so this little radius right here of the inside circle, or the hollowed out part, we'll call that little r, and we'll say that that's equal to 2 centimeters. So the way that we would find the volume of toilet paper in this roll would be pi r squared h minus pi r squared h. If we were going to do this with an integral, we would say the volume is equal to the integral of pi from 0 to 9.5. And it's 0 to 9.5 because that's the width of our toilet paper, or this washer that we have. We will end up calling this the washer method. It's going to be big R squared dx minus pi from 0 to 9.5 of little r squared dx. And you can rewrite that, we can simplify that by saying pi times the integral from 0 to 9.5 of big R squared minus little r squared dx. That's going to be the main equation that we use when working with this washer method. So down below, you can see it says washer method for solids with holes. So it's going to be pi. This is our generic equation from A to B of r of x squared minus, that's big R of x squared, I should say, minus little r of x squared dx. Or if we're rotating this about a vertical line, it would be pi from A to B of big R of y squared minus little r of y squared dy. All right, so those are our two equations. And here you can kind of take a look at a graphic here. Big R is the big radius, little r is the little radius. And in this particular problem, it's revolving around a horizontal line. So an example of this, number 6 says, find the volume of the solid formed by revolving the region bounded by the graphs of y equals square root of x and y equals x squared around the y-axis. So to do this, we're going to first sketch this out. So y equals the square root of x looks something like this, and y equals x squared, so we'll say square root of x, and y equals x squared looks something like this, right? And obviously this is a parabola, so it would continue on this side, but we only care about the region bounded by these two graphs. And it seemed like in our quiz today, this gave us a little bit of trouble, a little bit of a challenge to figure out what we meant by that bounded term. Just to reiterate, it's the region that is literally formed by these two lines, the space between them. So in this particular one, this is the region bounded by these two graphs. So we need two things. The first thing we need big R, and big R would be, oh, and I should say we're revolving this around the x-axis. So we're going from square root of x, because that's the one on top. That's our big R. And the x squared, that's the one on bottom, that's little r. All right, because you can think if we rotated this around, this would kind of look like, kind of like a weird looking bowl maybe. It wouldn't stand up very well because it would have a pointy bottom. But yeah, it would be kind of a weird like flower petal type thing. So what I want us to try and get in the habit of is to label them. So big R of x is going to be equal to the square root of x. Little r of x is equal to x squared. All right, and then we just plug into our equation. We get pi times the integral square root of x squared minus x squared squared dx. I should close those off. We should also figure out where do these two things intersect. Set them equal to each other, although I know you all know x is obviously going to be equal to 0 and 1 in this case. So we're going from 0 to 1 in our integral. Okay, and then we just solve these like we normally would. This is pi times the integral from 0 to 1 of x minus x to the 4th dx, which is equal to pi times x squared over 2 minus x to the 5th over 5 from 0 to 1. We get pi times 1/2 minus 1/5. When we plug in the 0, this is just 0 and it doesn't matter, so we can solve it right from here. This is pi times 5/10 minus 2/10, and we get 3 pi over 10 as our answer. All right. The next one, I want to look at one other problem. We're at least going to set it up. Yeah, it's this one. Okay, so it says find the volume of a solid formed by rotating the region bounded by the graphs of y equals the cube root of x plus 1, x equals 1, x equals 8, and y equals 2 around the line y equals 1. Okay, this is clearly something that we want to draw out because there's a lot going on in this problem. So let's sketch this out. I made that too big. Okay, so we have the cubed root of x plus 1. Remember, cubed root of x is like walk like an Egyptian. That's the shape. So we move up 1. And we're going to draw the cubed root of x plus 1. There we go. What else do we know? This is going from x equals 1 so x equals 1 to x equals 8. Okay. And it says there's also the line y equals 2. So we want to draw that in there. So that 2. All right, and we are revolving this around y equals 1. I'm going to draw a dashed line just so that we know what we're revolving around. So here's y equals 1. And we're going to revolve around this. So what does our area look like? Well, it's going to be this space in here. All right, and we need big R. This is big R, and this is little r. So big R, we should be able to tell, is the cubed root of x plus 1, but then we need to subtract 1 because we're revolving around the line y equals 1. We're not revolving around the x-axis. All right, and then little r of x, is just going to be 1, the distance between 1 and 2. Right? And then let's figure out where these intersect. So I get the cubed root of x plus 1 is equal to 2. Yeah, because I'm trying to figure out where the green and the purple lines intersect. And I get the cubed root of x is equal to 1. X is obviously equal to 1. All right, so we're going from 1 to 8. This is the cubed root of x, because this simplifies to, big R of x just simplifies to the cube root of x. So it's the cube root of x squared minus 1 squared dx. And I'll leave this one up to you to solve. Just a quick note. Remember that we can turn this cubed root of x into exponential to make this an easier one. It's x to the 2/3 minus 1 dx. In case you're like, I just need to know if this is the right answer, work your way through this. This is one that you should be able to do by hand. The correct answer, what you should get, is 58/5 pi. So see if you get that. If not, we can work through this tomorrow. And that's it. That's what I've got for you. We'll continue talking about these. This is called the washer method because you literally make washers. It looks like washers whenever you kind of like look at the cross sections. It's just made up of a bunch of different sized washers. Okay. Have a great rest of your day.